I was asked to say somebody about something as specific as a vertical wooden cladding. And my first idea was to say that if somebody wants a vertical cladding, somebody must tell him that is not absolutely the best idea. And that for many reasons, or for several reasons. First of all, it is definitely more complicated than a horizontal tongue roof or whatever cladding. It's definitely more expensive, not just because it's more complicated, but because we know we need a more complicated bearing frame. We need definitely what we call a cross frame. We have to work with loose pieces because there is no vertical facade system with tongue roof, which allows us to build relatively easy and not with a big knowledge and accuracy. But on a vertical facade, we always have to build with loose pieces, and we have to face, I would say, a bit more problems than with a horizontal facade at all. We have to, maybe I can say, we have to think more, and we have more details we have to be aware of. Besides, in fact, we built a double facade because in that case we need something like a protective foil in most cases, which is surprisingly not very cheap. I mean, it may cost 50% of the price of the boards itself. So that's one topic. The other topic is that architects love vertical cladding. And they love it so much that they somehow infect the investors without saying them all what I told you before. And it's a bit of a problem here. I'm a merchant, so we see it every day. We see every day inquiries for quite huge quantities of materials which can be just for vertical cladding. You cannot use it for anything else. And then we sometimes, if you have time, so we say, may I see a sketch of the project? And then we see those high buildings which have a wall of, I mean, high buildings, even if it's a family house, which have a vertical wall of 7, 8, 9 meters, and on the project there are these lines down, like nothing, just lines, and they come. Sometimes they even come and ask us for 9-meter long boards, planed and so on. Yeah. And they say, do you know what you're asking for? And did somebody tell you how it works if the water runs all these 8 meters down and soaks in? There's plenty of time to soak in, and the board, how the boards look like after being the 6th meter of a board which is exposed by not just by the spraying water but even by the soaking water. And these are not the right questions. So once we want to have a vertical cladding, and if we really want it, so we have to really, or not we, that somebody specific has to make himself responsible for the details. And this somebody specific can be probably just the architect, because nobody else in the chain is the one who could be responsible, who could either have his own knowledge or who can consult it quite easily, because it's not a big issue. It's just to know, to be aware of a couple of details, to be aware about the design itself, which may bring another couple of details, and then to say, okay, once I made these vertical lines on the facade, so I must explain to everybody after me how to deal with the details. If I don't, nobody will, be sure, and the decision will be somewhere around these not always very educated workers on the building side. I don't speak about soldering workers. I speak about our workers first. And if you decide them to, if you let them to decide about the details, and you are not so lucky that it's just Martin or somebody who is really very skilled in that, so you have a result which will probably look nice when you hand over the project or the building, but the problem is within a couple of years, where all this sins you made on these details will come out and will first of all not look nice, and sooner or later they can destroy your beautiful design and even the facade, which you see quite often. It's not so uneasy to walk through countries like my country or even Germany and Austria and see that not every detail on each wooden facade was made really happily. So, and the first problem is that, or maybe the only problem is that we must be aware of that running water, and we must not think that it will not run into every gap. It will, definitely. So we have to just think what happens with the water running down. First thing is we must forget about tone and groove, because that's maybe the best example. If you have a connection like a tongue groove like that, and the water runs through, so it definitely on a horizontal not, but on a vertical facade, it will definitely come into that tongue groove. That will cause a growing of the timber. It will close this gap, and this gap will stay closed with the water inside, which means that in this most vulnerable piece inside the wood, in this tongue groove, will the humidity stay for the absolutely longest time, and it will work on destroying that piece the longest possible time. The next problem is, even if you put some surface surface protector on that, you will probably not bring it into the tongue groove. So again, it's the most vulnerable part. So don't use tongue groove on vertical cladding. It is not the good way. It's just the way how to make the life cycle of that cladding very short. It will definitely look nice on the beginning, and it will be easy on the assembling. That's right, but that's all. So we must leave somehow all these vertical gaps open and ventilated, which is sometimes easy, sometimes it's not easy. Sometimes we just, and it's now not about telling you how to do specific things. You just must never close any gap on the facade, and you just must say, okay, let the water run in, because we have taken measurements to either to run out again or to dry through natural ventilation. And if you think about that, so we are more or less over. That's just the part. Normally, this is the most old-fashioned vertical facade, which is still being used, which you can use with different widths and make it more fashionable. But the problem is that mostly, very often, you find that board screwed on that board, which means that you produce a closed gap in here. And definitely the right solution, and definitely the more complicated solution, is to put into the gap of this board and this board another lat or whatever, which is a bit thicker, and screw that on that board. It's again not now a receipt how to do it, but it's just an idea what everybody should think about when he thinks about a detail on a vertical facade. The next very important thing is, once we want to have these vertical planks, we should try to break the water flow as often as possible. Every 2 meters, 3 meters, 4 meters. But please don't try to build these 6 or 7 or 8 meter long planks with water running down. It is technically very easy. It can be done by a metal sheet, it can be done by a wooden sheet, it can be done by many different, even nice looking things, but try as often as you can, maybe in the stories, maybe around the windows or whatever, make a horizontal line, so the water which runs down stops here, drops out, and doesn't run again on the surface, which will again save a lot of trouble to the wood. That's maybe another idea about this ventilated gap and the foil. We need that, or we think that especially for a hot climate country, the ventilated gap underneath the facade is absolutely essential. And a ventilated gap means a gap which is really ventilated in all its length. So there must be just vertical buttons, and we must always think where the air can go in, like here, like down there, and we must always think where the air goes out, like up there. And if we interrupt this flow by a window, for example, or by a door, we must again realize that this gap starts here. We cannot close that, because then we at least this 1 square meter make unventilated. And always, you don't see it here, but the nicest thing is if the ventilation soaks in possibly cold air from the bottom, from the air, and goes up. Even if you look around the house, and some places where it was natural, so we just connected that gap into the roof. So even the roof again, if the roof goes like that, so it again makes a chimney effect, and it soaks even more air from the ventilated gap. And by this gap, we just prevent overheating of the whole system, and that's what we always talk about. If we talk about preventing the house from overheating, it's much more efficient than a thick insulation, and definitely cheaper. But all you have to do is just not interrupt this ventilation, and not think that a gap of 1 or 2 centimeters will make it. For me, the minimum to achieve this effect is like 4, even 6 centimeters, and the buttons underneath, they are nothing extremely expensive. So there's definitely the wrong place to save money on that gap. And if you explain this to the investor, so he will understand it, because it's a very easy and primitive physical system. So he will know that you understand that you ask him you give him more space for his facade to ventilate, to prevent him from the heat. So that's another thing which even in the vertical facade we have to have in mind. Then, as I said, unfortunately we should use this foil, which should not be plastic. It should be a breathable foil. For me, it could even be a kind of mesh or whatever stops the waters which eventually sprays in through the facade from coming directly into contact with the insulation. If there is a little water coming close to insulation, it probably should not be a big problem, because first of all, most of these insulations are somehow protected against, not against direct rain, but against moisture. And second, if the ventilated gap works, so the water will evaporate quite quickly anyway. This could eventually, in some systems, save you the costs for the foil.
Top of the insulation or behind the insulation?
No, you must put the foil on the outer side of the ventilated gap. The ventilation of the gap will happen between the insulation and the foil.
Okay.
Definitely. You must not protect. Normally, it depends, of course, on the data sheet of the insulation. If the insulation is designed to survive in, let's say, natural 60, 80%, 90% of humidity, so then you don't have to protect it. For me, the less plastic and the less foils you put in any construction, the better for you. So that's why I never plastic it. It is more a mesh than a foil.
Well, we call it a breather membrane. It's got to be able to let moisture out.
Exactly.
And most of the stuff you buy here with tin aluminium is not.
Succinylation would not be
No,
satisfactory. You want
succinylation is
something
not-
that's permeable.
Succinylation is not approved.
Yeah.
But that, I can go into, I use type.
I don't trust that any of these breathable foils really breathe.
Well, this is an American one. It's been approved here and the only one that's been approved here.
What is it called?
Tyvek, Tyvek.
Tyvek.
Yeah.
Yeah. You know, I cannot argue
It's got holes in
with.
it. It lets the air breathe out. That's very important. Otherwise, because we have a condensation area here in the cake.
It's all about that. What I've been told is it's all about that there are little holes which are big enough to let the air out and small enough to let the air out and big enough to let the moisture in.
And not let moisture in. You don't
Yeah,
want that.
but for that purpose we need here even as a very small mesh will make the job. We just want to make because we cannot guarantee that through these systems water comes in, and all we want to have is some barrier where the splash water stops and runs down. That's nothing else. It's just, and then of course we would like to avoid insects and small animals crawling into the insulation. That's the second effect, which again, if the mesh is small enough, makes the job. So it must not be any kind of a high-tech product. It just, and because it's hidden from the UV mostly. It depends if you use a facade like that. So you should have something UV stable. If you put it under a facade like that, where you know that the light is not going through, so you can again go for a easier product. Maybe to this facade, I put it just on because it's now becoming like a fashion to make vertical facades of big pieces of timber. It looks nice, it looks massive. We love it because they use a lot of timber, and they pay for that. And in fact it's something quite durable, because the bigger the piece of timber, the bigger the durability, obviously. And architects play with different sizes and different directions of fixing, and for me it doesn't look so bad. It's something new. It's something definitely more modern than this. So it's just an idea with 2 or 3 dimensions of planks like that. You can make a very modern vertical design. Maybe I don't know if you see that I cut all ends, and this is like 15 degrees. It must not be 15 degrees, but it must definitely not be 90 degrees. We always have to produce this, I call it dripping edge forever. So that's very important. And if it's 10 or 15 or 20 degrees, it's up to a design, but there must be a visible, one visible edge to allow the water to stay there and then drop if the drop is big enough. This is, by the way, a combination just about offcuts, but that's Siberian larch, the lighter things, and that's thermotreated pine. If you leave it outside, so in a couple of months they will all look the same. They will all be gray. You would see it just if you touch it or if you take it in your hand, because the Siberian larch is more heavy. But if it goes for a facade, so it is not easy to decide between Siberian larch and thermotreated pine, because the larch has some advantages and disadvantages, and the pine as well. and the price is very similar. So it is a lot of much more about emotions or personal preferences or whatever. This piece I put just for not to forget that we should never end with a wooden facade on the ground. We should always have, we say, 30, 40, the more the better centimeters, to avoid the water which drops on the ground to spray back on the facade, giving this lower part of the facade a double portion, which doesn't look nice. It will make the eldering process of the bottom part much faster. So if your design can accept it, so try to make half a meter, 60 centimeters or whatever of a cement fiber board, or it's very up to your design. It even can be just a horizontal profile like that, and the idea could be that you can change it in 10 years when it doesn't look nice anymore. But it should be something different, because if this is then a 4 meter long piece and the lower part is really not nice anymore, so you have to change it all. If you allow, once you want to have it to the bottom for different reasons, so try to think about this last piece being able to change without big efforts, because that is one of the big arguments for wooden facade. It is really easy to change. It's really easy to put another cable underneath it. If you give me a screwdriver, so I can open that within 5 minutes and put a new wiring underneath, or look what happened and whatever. That's one of the big advantages of any wooden facade, which is screwed, which is not. And please use always screws, and please always use stainless steel screws. It is definitely worth the money, because everything else which is not stainless and good quality stainless screw will not survive, and it will cause unnice places on the facade.